All right, camera's on. I sure hope the audio is on, or this section's really going to suck. All right, welcome to Old Man Maker. My name is Brennan, and I am indeed the old man who makes stuff. What sort of stuff? Well, I work on everything from hardware to software to electronics, 3D printing, woodworking, metalworking, and sort of everything in between. And that's the sort of content that we're going to be showing on this channel. Now, I've been working as a professional software engineer for over 30 years for some of the biggest companies in the world, and I've worked on some really cool projects along the way. But the last 15 years I've spent sort of focusing very much in robotics and humanoid robots at that, and a lot of advanced AI. The challenge with that is that I can't talk about a lot of that work. I can't share a lot of that work for various reasons. But also along the way, there's a lot of projects and ideas and things that just come up, which would be just cool to work on just because they sound fun. But also they probably, in some way, shape or form, give me the opportunity to learn more and more and more. That's sort of the idea. So I wanted to create a YouTube channel that would perhaps let you follow along with the processes and the way that someone like me thinks about building products, exposing you to some of the tools, some more professional level tools possibly, and just bits and pieces like that as well. So we're not going to get to the end of 20 minutes and ta-da, have a product to show, but it's sort of the possibility of chopping and changing, jumping in and out of different projects over different videos and things like that as we go. Anyway, enough yabbering. You know that this particular project is about thinking about creating a little robot, a little physical robot. It's part of a bigger concept and idea around physical and digital gaming. Now, whether that is viable or not just depends. So what we're going through here is a validation sort of step in that idea. I'll talk more about that idea, that gaming concept and stuff throughout the videos as we get going. But for now, the first place to start really is at the computer. It's about coming up with a visualization of what it is that we want to build. So let's jump into it. I'm sure most of you will recognize this tool. Obviously, it's ChatGPT, which is making some parts of the product design process happen much faster. So given we spent several days already discussing and documenting the idea, it then becomes pretty easy to come into ChatGPT and start creating concepts. Now, here I'm trying to narrow it down as quickly as possible. It's pretty frustrating for the most part, and it doesn't get the concept of only having 3 wheels. But after taking all of that sort of inspirational guides and producing several images that I like, I can then send them out to other people to get their feedback on it as well. Now, as it turns out, when we get through down, we start getting into some pretty good details here. I sent a number of these to a few friends, but as it turns out, we all sort of most of us settled on this image being the one that is closest to the concept story of a little robot type rover that could be mining off planet or here on Earth, something not too scary. It sort of should be quite industrial looking, but also some form of advanced functionality through its appearance. And I think this sort of really works for this idea for our concept. So great, now we've got a concept to work with, and you can go through and do this sort of process as well, of course, but now I want to quickly show you through some of the key areas that we should be thinking about as we start the design process. Here we're inside a tool called Visio, which is great to sort of block diagram things out nice and quickly. In this case, I'm going to use it to sort of explain a few more details. And we're seeing several lists of some of the key parts of the process, along with the key considerations. This certainly isn't an exhaustive list, as some of these items could very much contain hundreds of tasks to actually complete them. Right now though, I want you to focus on this part, on the hardware part itself. This part of the process, we're trying to reach a milestone, what is called a looks like prototype. Now, this means, as the name suggests, that we get a pretty good indicator of size and scale, something we don't get just looking obviously at a concept image. We'll come back to this collection of items as we sort of progress through the videos, and as we need to tick them off, so to speak, or reference how some things will be dependent on each other. For now, let's jump into our primary mechanical design tool for this project and start to consider how and what we need to do first. So here we are in a fantastic tool called Onshape. This is a web-based tool that lets us really construct the parts, the components, and all the things that will eventually make the entire product. Now, Onshape are not supporting this video, and even if they were, I'd still be saying the same thing. I mean, given all the professional level tools out there, I think Onshape and the supporting team behind it really have the best product in the market. Okay, so this is where we start in what is called a part studio. Down in this tab, you can see it's just called top pyramid, and this means this is where we design all the parts that can be used later on in what is called an assembly. And you can see in this one, I've started with a structure that vaguely looks like a cut-off pyramid. Now, to understand why I've gone with this structure, I think it's we can quickly go back to our concept art, and I'll walk you through how I think about the concept, how I break it down, so I can then start working inside of Onshape to sort of bring that idea to life. So, like in most forms of design, we typically work through a process of blocking things out and slowly moving down through the levels, adding more meat on the bones, and as we go in terms of the details. Now, when I see this image, I immediately block it out into two sections. There's a sort of natural top and a bottom part. I look at the details here, and without getting into deep just yet, I'm recognizing that I need a cut-off pyramid type structure. I need some plates. I need a screen here out front, and probably some speakers on the side as well, etc. I'll come back later on to pick up more details around the top section as well. Now, for the moment, I'm not going to spend too much time on the details of the lower half. I recognize that it's probably an inverted pyramid as a base. I do see some funky stuff with ChatGPT where it's put an axle through the wheel here. Yeah, so much for reasoning, eh? Anyway, I'll start to work out the base as we get to it. So for now, let's just get back into the design so we can get on and start making stuff. So now you can see that I've used this pyramid structure as a base to create the components. And I want you to pay attention to just how complex these shapes are, even at this first stage. Now, let me just turn them on. I've gone ahead and sort of designed them. There's a side and a base, and you might have just seen them turn on. In fact, I can turn off the pyramid that we used. And as I was saying, have a look at just how complex those shapes actually need to be to make the cut-off pyramid. I mean, you've got some pretty funky angles coming in, even with these curves and things like that. Okay, but anyway, from here we can also create some blocks that represent our corner pieces. I think actually if I turn the pyramid back on, it'll probably make more sense. I can put them in. Let me just turn them on. And we're sort of just putting them on there at the moment just to make sure that we're going, we're going the right way. We're looking similar to our concept. Now, remember, this is a looks like prototype, not a photo image replication prototype. We're the ones that get to make the changes on the fly as we're designing this. So the cool thing is that we can now come into the assembly itself. Now, this assembly is what where we can start to bring all of our components together. We can bring multiple instances of those components. You remember I just designed the one top piece, one side piece, and one bottom piece. I'm able to bring multiple instances of them together to make sure the geometry is correct, to make sure that we get our sort of cut-off pyramid structure. For now, we want to produce just the front plates and the mechanisms to hold the screen in place. So right now, I'm not going to produce any of these corner pieces, any of the frame of the pyramid. We're literally just on the front plate and all of these component pieces here. All right, let's get into that. All right, so don't mind me. Obviously, this could be nice if it was on a table, but I haven't got the tripod positioning at the moment to be able to do that. Plus, the desks are a bit of a mess. So I wanted to go through a couple of the components that we first printed. As you saw, we sort of went through to print the initial inner layer that will hold the screen. Now, what you'll see in here, and hopefully that will focus up for us, is this component, as you can see, has got a few brakes on it, a few chips in it, and it's got a lot of blue markings on it. So these markings are, as I'm going through and I'm trying to fit the components, as I'm building them, I'm making notes. I'm sort of marking them physically so I can, understand what I need to change. But then I'm going to go back in on the computer and make a list of these changes that I need to refer to. Now, we've gone through a couple of sort of simple prototyping layers at the moment. Two, I think we're on the third run. This is the internal component. So this particular piece is going to sit in, well, we need another framing component piece. I don't think I've got one. Did it break? Breaking these components is quite interesting because we're trying to sort of figure out, tension, weak spots and so forth. But that actually went on like that, right? This piece went on here, there, the little screen went in, and then it all sits up inside this piece. Now, what I could also see from this initial piece was that it was just too tight, okay, and it started to deform. It deformed this piece, hence the break, and deformed the other piece, hence the way that shattered. And it's a really important reason why we don't stick the actual screen component in there to begin with. Now you can see I've made markings on this one as well, looking at the inside thickness of this wall, the outer edge of this wall, and then we start off with some of the, some of the real outer edge pieces as well. Where are we now? If we look at our latest third run prototype, you can see that here we now have the sort of smoother beveling on the outside. We've got a lot more meat here for the embedded nuts. This is not about the hole positioning. It's about sort of when you put a nut in here, a cap head nut, it'll create a gap. So we may have to flatten that out as well. There's now there's now a ridge inside, so it fits flush. It's a very, very tight fit. This is a very tight fit. It's a push fit, because you got to remember we're trying to hold all of this together to make sure it's not going to go anywhere, obviously. But it's also housing components that we just don't want to break. So let's have a look. Our first plate was nice and simple. I mean, we're going to iterate this a bit more as well, but at least giving us some idea of how everything is going to come together. And so our plate is looking, and of course, crucially, we're making sure we've got clearances. We're making sure that actually we're going to be able to mount this and affix it, and make sure it isn't going to move anywhere as well. So we can start to work with the screen component. There's plastic on top of it so it doesn't get damaged. We really got to think about making sure we don't damage these components. But effectively, that is then going to go in here. Something similar to this mechanism. It's a tighter mechanism, but we start to get some idea of how that plate is going to come together and what it's going to look like. Obviously, it's not painted or anything like that. We're just trying to get the assembly and the mechanical parts of the components together. All right, so now let's move on to some electrical prototyping, which can be a really fun part of the process. It can also be an incredibly frustrating part, but more on that later. Generally, it takes a really long time in terms of research to figure out all of your component parts that you want to use in an entire project. So at this stage, all we simply want to do is we want to block it out to the highest levels like we do in our mechanical design, and so we can do that by using complete modules of parts. So we're doing what we call module prototyping here. That is taking a single component as a complete module, the little screen here that you can see the actual size of, and hooking that directly up to a microcontroller, also known as an MCU. In this case, our MCU is an ESP32 S3 chip that you just saw me soldering the header pins onto. Now, if you're familiar with Arduino boards, the ESP32 has a lot of similarities, can use the same environments and the same code, but it also is much more powerful, and it comes with a host of other advantages that we'll get into throughout the rest of the videos in the series. After figuring out some details of the screen, I'm now soldering some wires to it, taking a lot of care due to it being so fragile, but I'm also thinking about how it will be mounted in the little screen holder itself. Once we get that all wired up, we can write some simple code to get our screen up and running, which is always a great little milestone to hit. So next we want to get the screen into place. So we're going to fit it and then assess if we've introduced any new problems or now need to modify that component again. In this case, I now know that the component that holds the screen needs another iteration to enable it to be seated in an easier way when the wires are attached to it. It was just too tight before. So we have to go back to OnShape and we'll make some adjustments, sort of just as we marked it up on the component itself. Alright, so we're back in OnShape and now we've got to make those changes. We've made this opening much wider and we've also put a little bit of a chamfer just on the inside to make it easier to mount the component. Right, so let's head back to the Resin 3D printer and print out the updated part again. Alright, so once again we go through cleaning up the part, we're removing supports and generally ensuring that everything is smooth and ready to try the screen again. All right, so that's about it. I mean, it probably looked like it all went together nice and easy and seamlessly, right? Well, I guess that's the point, and in reality, it certainly did not. And that's the things that are, I guess, masked by some of the other formats of YouTube sort of videos that you might be seeing. The reality was that when I actually took out the little board, the ESP32, the microcontroller to power the screen, from the moment I took that out of its packaging to the point where I actually got colors on the screen, it took just under 14 hours. That was a 4 a.m. finish. And why? Because several things along the pathway of bringing all that together were broken. Now, that's the challenge when you're working in this sort of thing. You cannot expect it to work first time. If it does, go outside and scream because that's pretty amazing. It happens so infrequently. It's not even funny really. It's annoying. But we go through this problem whenever we're working hardware, electronics, software. We have components that are out of our control, and if you really want to do this sort of work and these sorts of projects, it's about persistency, and it's about fighting through and finding alternative routes to solve a problem. A lot of the time they're not even problems that you created. Sometimes they are, and actually in bringing that up, from the moment that I actually produced the first screen and got it up, you'll see that I needed to remark some of the little casing that holds this little screen in place. Well, in the process of taking that in, taking that out, a tiny little piece of the ribbon cable broke. I think I'm going to show you some of that under a microscope. It's tiny, but that was actually what was then causing the screen not to display as well, which was another problem. That led to another iteration in the design to improve it so that wouldn't happen again. My point being is that these little components are really, really fragile. Some are pretty robust, but a lot of them are really, really fragile. Now, these are really inexpensive, so I always order at least two, try to order a few more if I can afford it, but you know, when you're working in these sorts of projects, it's something to keep in mind that in prototyping you will most likely break stuff all the time. Nevertheless, we got another one wired up, we got another component done through another iteration, and hooked it all up, and everything works, which is great. All right, so we've had a look at all the tools, we've had a dive about the process. We're going to go into a lot more as we go. If you've liked this sort of content, then I really need to hear that. I'd love to hear your feedback and your thoughts in how to improve things, what you think of this and that, and what you'd like to see, of course, down in the comments. That would be amazing. By now, you all know what to do if you really like something, is to thumbs it up, subscribe to the channel. You really need to help the algorithm decide whether it should show this video on this channel to other people, which is, of course, what we need it to happen to keep continuing. Okay, next time around, we're going to concentrate on the framing of the top pyramid. We're going to build that out. We're going to build some side panels, and I'd love to get a start on just the prototyping of the audio, some speakers in there, and have a discussion around some of those parts as well. So that's next time. I hope you enjoyed it, and take care. I'll see you in the next one.